Carrier wave of peak voltage 15 volt is used to transmit a message signal. What should be the peak voltage of the modulating signal in order to have a modulation index of 40%? Here are the options. Now we know that the modulation index mu is equal to AM upon AC. Therefore, in order to find AM will be equal to mu into AC. We know that mu is 40%, so it is 40 upon 100. And we know that AC is equal to 15, which is given right here, into 15. So the answer is 6 volts. So the correct option is option B. Signal wave of frequency 12 kHz is modulated with a carrier wave of frequency 2.51 MHz. What are the upper and lower sideband frequency? So here are the options. Now the signal wave Fs is equal to 12 kHz and the carrier wave Fc is equal to 2.51 megahertz, which we have to convert into kilohertz, which after converting will become 2510 kilohertz. Now the upper sideband frequency will be Fs plus Fc, which will be equal to 2522, and the lower band frequency will be Fs minus Fc. I'm sorry, Fc minus Fs, which will be equal to 2510 minus 12, which will be equal to 2498. So the correct option is option D, 2522 kilohertz and 2598 kilohertz. Transmitting station transmit radio wave of wavelength 360 meters. What is the inductance of a coil required with a condenser of capacity 1.20 micro F in the resonance circuit to receive the radio waves? Here are the options. Now first we find the frequency of the radio waves, which is given by V is equal to C upon lambda. Substituting the values of C and lambda from here we get upon 360, which is 1.12 into 10 raised to 7 hertz. Now the resonant frequency is given by V is equal to 1 upon 2 pi root LC. Now squaring both sides to remove the square root, we get V square is equal to 1 upon 4 pi square L into C. We have to find the value of the inductance of the coil, which is L. So transferring L on the other side, we get 1 upon 4 into pi square into V square into C. Substituting the value of pi square, which is 10 given here, V square, which is here 1.12, and C, which is given as 1.20, we get the answer as 3 into 10 raised to minus 8 Hz. So the correct option is option C. Communication system operating at 1200 nanometers, only 2% of the source frequency is available for TV transmission, having a bandwidth of 5 MHz. The number of TV channels that can be transmitted are, here are the options. Now, first you have to find the frequency of the source, which is given by V is equal to C upon lambda, which is equal to 3 into 10 raised to 8 upon 1200 nanometers, which is 1200 into 10 raised to minus 9 meters. So, this gives us the value of 25 into 10 raised to 13 Hertz. Now, only 2% of the source frequency is available. So 2% of this will be 2 upon 100 into 25 into 10 raised to 13, which is equal to 5 into 10 raised to 12 Hertz. Now, so therefore the number of TV channels available will be equal to total bandwidth upon bandwidth per channel. Bandwidth per channel. So the total bandwidth will be this, which is 5 into 10 raised to 12, and the bandwidth per channel will be 5 megahertz, which is 5 into 10 raised to 6, which is equal to 10 raised to 6, which is equal to 1 million. So the correct answer is option A, 1 million. A communication channel having an operating wavelength of lambda meters can use only X% of its source frequency as its channel bandwidth. If the system is to be used for transmitting TV signals requiring a bandwidth of F Hz, how many channels can this system transmit simultaneously? Here are the options. Now, first we have to find the source frequency, which is equal to F is equal to C upon lambda. Now, the bandwidth can use only X% of its source frequency. Therefore, X% of the source frequency is X upon 100 into C by lambda, which is equal to XC upon 100 lambda. Now, the number of channels will be equal to total bandwidth upon bandwidth of each channel. Bandwidth of each channel. Now total bandwidth is xc upon 100 lambda. So xc upon 100 lambda, and the bandwidth of each channel is f, which is equal to 1 upon f. So the correct option is option A, xc upon 100 lambda f. The length of a half wave dipole antenna at 30 megahertz. These are the options. Now the length of the dipole antenna L will be equal to lambda upon 2. Now in this problem, lambda is equal to C upon F, which is equal to 3 into 10 raised to 8 upon the 30 megahertz, which is 30 into 10 raised to 6 meters, which will be equal to 10 meters. So L will be 10 upon 2, which is 5 meters. So the correct answer is option B. The highest modulating frequency of a wave is 5 kHz. The number of stations that can be accommodated in a 150 kHz bandwidth is, here are the options. Now, the bandwidth, the B width of wave per station will be equal to 2 into the highest modulating frequency, the highest FM, highest modulating frequency, which here the highest modulating frequency is 5 kHz, which will be equal to 2 into 5 kHz, which is equal to 10 kHz. So now the number of stations will be equal to total bandwidth upon bandwidth per station. Here the total bandwidth is given as 150 kilohertz and the bandwidth per station is 10, which is upon 10 kilohertz, which will be equal to 15. So the total channels can be accommodated is 15. So the correct answer is option A. Be the minimum electron density in the ionosphere for the sky wave propagation of a 9 megahertz channel. Here are the options. Now, for the sky wave propagation of a given signal, the critical frequency Vc is given as Vc is equal to 9 into Nmax root of Nmax, where Nmax is the electron density. Here, so squaring on both sides, we get Vc square is equal to 81 into Nmax. Here, we have to find the value of Nmax. Therefore, Nmax will be equal to Vc square upon 81. Now Vc is given as 9 megahertz. On substituting, we'll get the answer as 10 raised to 12 per meter cube. So the correct answer is option B. The central operating frequency of a microwave telephone link is 8 GHz. 5% of this frequency is available for microwave communication. How many telephone channels can be operated simultaneously if the bandwidth of each telephone channel is 5 kHz? Now, the frequency available for microwave communication is 5% of 8 GHz. Now gigahertz, 1 gigahertz is equal to 10 raised to 9 hertz. So 5 upon 100 into 8 into 10 raised to 9 will give the answer as 4 into 10 raised to 8 hertz. Now the bandwidth of each telephone channel is 5 kilohertz, which on converting into hertz will give us 5 into 10 raised to 3. Now number of telephone channels that can be operated will be equal to 4 into 10 raised to 8 upon 5 into 10 raised to 3, which gives the answer as 0.8 into 10 raised to 5, which is equal to 8 into 10 raised to 4. So the correct option is option B. A modulated carrier wave has maximum and minimum amplitudes of 900 MV and 300 MV respectively. What is the percentage modulation index? Here, Amax is equal to 900 megavolts and Amin is equal to 300. Now the formula for percentage modulation index will be mu is equal to A max minus A min upon A max plus A min into 100, which will be equal to 600 upon 1200, which will be equal to 50%. So the correct answer is option C, 50%. The maximum peak to peak voltage of an AM wave is 16 MV and the minimum peak to peak voltage is 4 MV. What is the modulation factor? Now, since in the question it is given as peak to peak voltage, we take the half of both the values. Therefore, Emax will be equal to 16 upon 2, which is equal to 8, and Emin will be equal to 8 4 upon 2, which is equal to 2. Therefore the modulation factor with mu is equal to E max minus E min upon E max plus E min, which will be equal to 6 upon 10, which is equal to 3 by 5. Therefore the correct answer is option D. A sinusoidal carrier voltage of 120 volt is amplitude modulated by a sinusoidal voltage of frequency 10 kHz. What is the modulation index if the maximum modulated carrier amplitude is 150 volts? Now here EC, which is the amplitude of the carrier, is given as 120 volts, and A max is given as 150 volts. So we have to first find out AM. Therefore, AM, which is the modulating, AM will be equal to A max minus AC, which will be equal to 30 volts. Now, the modulation index mu is given by AM upon AC, which is equal to 30 upon 120, which is equal to 0.25 or 25%. So the correct answer is option B. When a sinusoidal carrier wave of voltage amplitude 3 kilovolts is amplitude modulated by a sinusoidal signal voltage, two sidebands each of amplitude 600 volts are produced. What is the modulation index? Here are the options. Now, the amplitude of each sideband is given by the formula mu into AC upon 2. Now the amplitude of each sideband is given as 600. So 600 volts, we go to mu into AC, which is 3 kilovolt, which is 3 into 1000 volts upon 2. Now we have to find the value of mu. So mu will be equal to 600 into 2 upon 3 into 1000, which will be equal to 1200 upon 3000, which will be equal to 4 upon 10, which will be equal to 0.4. So the correct answer is option D. An audio signal given by E1 is equal to 12 sine 2 pi 2000t amplitude modulates a sinusoidal carrier wave. E2 is equal to 50 sine 2 pi 100t. What is the upper sideband frequency? Now, the standard equation is given by E is equal to A sine 2 pi nt, where nt is the frequency. So, comparing E1 and E2 with this equation, we get Fm is equal to 2000 hertz, which is equal to 2 kilohertz. This is the frequency of the modulating signal, and we get Fc is equal to 100,000 hertz, which is equal to 100 kilohertz. This is the frequency of the carrier wave. Now upper sideband frequency is given by Fc plus Fm, which is equal to 100 plus 2, which is equal to 102 kilohertz. So the correct answer is option D. For an amplitude modulated wave, the maximum and minimum amplitude are 10 volts and 2 volts respectively. What is the modulation index? Now, first let's assume AS is equal to the amplitude of the signal wave and AC be the amplitude of the carrier wave. Therefore, we have A max is equal to AC plus AS, which is given as 10 volts, which is equal to 10. And A min will be equal to AC minus AS, which is equal to 2 volts. Now, on adding these, we get 2 AC is equal to 12 volts. Therefore, AC will be equal to 6 volts. And on subtracting these, we'll get AS is equal to 4 volts. Now, the modulation index, formula of modulation index is mu is equal to A max minus A min upon A max plus A min, which will be equal to 8 upon 12, which is equal to 2 upon 3. So the correct answer is option C. Short wave communication, waves of which of the following frequency will be reflected back by the ionosphere of electron density 10^11 per meter cube. Now, the critical frequency Fc is equal to 9 into n max raised to half, where n max is equal to the electron density. So we have to find Fc. So Fc will be equal to 9 into 10 raised to 11 raised to half, which is equal to 2.8 into 10 raised to 6 hertz, which is equal to 2.8 megahertz. Now rounding this off to 2.2, which is equal to 2. So the answer is option A. For skywave propagation of a 10 MHz signal, what should be the minimum electron density in ionosphere? Now the formula for the critical frequency Fc is equal to n9 into n max raised to half. Here Fc is given as 10 MHz, which is 10 into 10 raised to 6 Hz, is equal to n9 into n max raised to half. On squaring both sides, we will get 10 into 10 raised to 6 the whole square, 81 into n max. Therefore, n max is equal to 100 upon 81 into 10 raised to 12, which is equal to 1.2 into 10 raised to 12 per meter cube. Therefore, the correct answer is option A. Maximum distance up to which TV transmission from a TV tower of height h can be received is proportional to, here are the options. Now, the distance d up to which TV signals from a TV tower of height h can be received is given by d is equal to root of 2rh. Therefore, d is directly proportional to root of h, or therefore d is directly proportional to h raised to half. Therefore, the correct answer is option A. In communication with the help of an antenna, the height h is doubled. What is the new range if the initial range was r? So let the initial range r is equal to root of 2rh, where r is the radius of the earth. Now since h is double, so the new range will be equal to r dash is equal to root of 2r into 2h, which is equal to 2 into 2rh, where root of 2rh is r. Therefore, it will equal to root 2 into r. Therefore, the new range will be root 2 into r. So, the correct answer is option A. Electromagnetic waves of frequencies higher than 9 root 2 MHz are found to be not reflected by the ionosphere on a particular date at a place. The maximum electron density in the atmosphere is, here are the options. Now, for ionosphere propagation, the critical frequency EC is given as n into root of n max, where n max is the maximum electron density. We have to find n max. Therefore, n max raised to half will be equal to Vc upon 9. Vc is given as 9 root 2 megahertz. Therefore, equal to 9 root 2 into 10 raised to 6 hertz upon 9, which will be equal to root 2 into 10 raised to 6. Now, on squaring both sides, we get n max is equal to 2 into 10 raised to 12 per meter cube. So, the correct answer is option C. A sinusoidal carrier wave of amplitude 80 volts and frequency 600 kHz is amplitude modulated by a sinusoidal voltage of frequency 30 kHz. What is the ratio of the upper and the lower sideband frequencies? Here are the options. Now, here the frequency of the carrier wave Fc is equal to 600 kHz, and the frequency of the modulated wave is Fm is equal to 30 kHz. Now, the upper sideband frequency USB will be equal to 600 plus 30, which is equal to 630 kilohertz. And the lower sideband frequency LSB will be equal to 600 minus 30, which is equal to 570 kilohertz. Now, the ratio of the USB and LSB, that is upper sidebands and the lower sideband, will be equal to 630 upon 570, which is equal to 21 upon 19. So the correct answer is option B. Transmitting antenna at the top of a tower has a height of 50 meters and the height of the receiving antenna is 32 meters. What is the maximum distance between them for satisfactory communication in line of sight mode? Here the radius of the earth is given as 6.4 into 10 raised to 6 meters and root 10 shall be taken as 3.16. Now the maximum distance dm will be equal to root 2 into r into ht, which is the height of the transmitting antenna, plus 2 into r into hr, which will be the height of the receiving antenna. So by substituting the values, we get 2 into 64 into 10 raised to 5 into 50 plus root of 2 into 64 into 10 raised to 5 into 32. So on calculating, we get the answer as 45.5 kilometers. So the correct answer is option D. What should be the length of a half-wave dipole antenna required to transmit audio frequency signals? Now, here are the options. Now, audio signals have frequency range of 20 Hz to 20 kilohertz, which is equal to 20 into 10 raised to 3 Hz. Therefore, the frequency of audio signals will be f is equal to 20 into 10 raised to 3 Hz. Now, the corresponding wavelength lambda will be equal to c upon f, which is equal to 3 into 10 raised to 8 upon 20 into 10 raised to 3, which is equal to 15 kilometers. Now the length of the dipole moment L is equal to C upon 2F, but lambda is equal to C by F. So substituting C by F, we get lambda by 2, which is equal to 7.5 kilometers. Therefore, the correct answer is option D. If the frequency of the carrier wave is increased from 10 MHz to 100 MHz, the length of the half-wave dipole antenna required for transmission A increases, B decreases, C remain constant, and D will be doubled. Now the length of the dipole antenna L is equal to C upon 2F. Therefore, L is inversely proportional to 1 by F. So if the frequency increases, then L will decrease because they are inversely proportional. Therefore, the correct answer is option B. In an amplitude modulation diode detector, the output circuit consists of R is equal to 1 mega ohm and C is equal to 1 picofarad. What carrier frequency it can detect? Here are the options. Now, to recover the audio signal in an AM detector, the output is fed to a parallel combination of a low value capacitor C and a resistance R. And for demodulation, which is detection, the following condition must be satisfied. 1 upon Fc is less than Rc. Here, in this case, C is equal to 1 picofarad, which is equal to 10 raised to minus 12 farad, and R is equal to 1 mega ohm, which is equal to 10 raised to 6 ohms. Therefore, Rc will be equal to 10 raised to 6 into 10 raised to minus 12, which is equal to 10 raised to minus 6 seconds, since 1 by F is measured in seconds. Therefore, 1 by F is less than Rc. Therefore, frequency Fc will be more than 1 by Rc, which is equal to 1 upon 10 raised to minus 6, which is equal to 10 raised to 6, which is equal to 1 megahertz. So the correct answer is, thus the carrier frequency should be more than 1 megahertz. Therefore it can detect frequency of 2 megahertz. So the correct answer is D. For an amplitude modulated wave, the maximum amplitude is found to be 15 volts, while the minimum amplitude is found to be 3 volts. What is the modulation index? Now, the modulation index mu is equal to A max minus A min upon A max plus A min. So, 15 minus 3 upon 15 plus 3, which is equal to 12 by 18, which is equal to 2 by 3. Therefore, the correct answer is option C. For a good demodulation of an amplitude modulated signal of carrier frequency f, value of Rc should be such that, here are the options. Now, to recover an audio signal of AM in the AM detector, the output is fed to a parallel combination of a low value capacitance and a resistance R. And for demodulation or detection, the following condition must be satisfied. 1 upon Fc should be less than Rc. Therefore, the correct answer is option C. The TV signals have a bandwidth of 4.5 MHz. How many channels can be accommodated in a bandwidth of 27 GHz? Now here the bandwidth of the channel is given as 27 GHz. Now 1 GHz is equal to 10 raised to 9 Hz. So 27 GHz will be 27 into 10 raised to 9 Hz. Now the bandwidth of the signals are given as 4.5 MHz, which is equal to 4.5 into 10 raised to 6 Hz. Now the number of channels will be equal to 27 into 10 raised total bandwidth upon the bandwidth per channel, which is 4.5 into 10 raised to 6 will be equal to 6 into 10 raised to 3. This is 10 raised to 9, I'm sorry. And the answer is 6000. So the correct answer is option C. The antenna current of an AM transmitter is 8 amperes when only carrier is sent, but increases to 8.96 amperes when the carrier is sinusoidally modulated. The percentage modulation is, here are the options. Now, we know that IT upon IC the whole square is equal to 1 plus M square upon 2, where M is the modulation index, percentage modulation. So here we know that IT is given as 8.96 amperes and IC is given as 8 amperes. So on substituting the values of IT and IC in this equation, we get 8.96 upon 8 the whole square is equal to 1 plus m square upon 2. Now, therefore, on calculating this value, we get 1.254 is equal to 1 plus m square upon 2. Therefore, m will be equal to 0.71, which is equal to 71%. Therefore, the percentage modulation is 71%. Therefore, the correct answer is option D. A transmitter supplies 9 kilowatt to the aerial when unmodulated. The power radiated when modulated to 40% is, here are the options. Now, we know that PT is equal to PC into 1 plus m square upon 2. Here, PC is given as 9 kilowatts and m is given as 40%, which is 40 upon 100, which is equal to 0.4. Therefore, substituting the values, we get PT is equal to 9 into 1 plus 0.4 the whole square upon 2, which is equal to 9 into 1 plus 0.16 upon 2, which is equal to 9 into 1.08, which is 9.72 kilowatts. So the correct answer is option B, 9.72 kilowatts.